Okay. So good afternoon. Let us start solving the problems in homework number 10. The first question, let me show you and read it together. So if the line y equals to 3x plus a is tangent to the graph of this function at t equals 1 and 2, then what is a minus b plus 2c? Yes? So I need to write the information here. So question number 1, and I want you to learn, because as I told you, the questions are algebraically very simple. The calculations are not heavy at all, as you will see. A line is given to you, y equals to 3x plus a. This is given to be the tangent line. You know that when you have a tangent line, you also have a point of tangency, the point at which the line touches the graph. And that point is also given to you. T is 1 and 2. And the function is also given to you. F of x equals to bx squared plus x, yes, am I right, plus x plus c. And now you are supposed to answer the question mark, which is equal to a minus b plus 2c. This is wanted. Okay, so in other words, this is asking you to find a, b, and c, and put them here and find this answer. In autocorrection questions, you will get sometimes something like this. Or if this is coming in the national exam, they might ask you find A, B, and C. But because I want to design it in an autocorrection format, I have to make it in a way that it can correct it for you. Okay, so this problem is a very typical problem, so you need to understand that. So if this picture, you go to a scratch paper, these problems need going to a scratch paper and analyze the problem. So what you do, and you don't need to be precise at all, okay? So you have a line, you have a function, you know that the line is tangent to the function at that given point. So try to sketch a graph, and don't care if the graph is even close to be real. You don't need that, okay? And then I have a line that is supposed to touch. It should be tangent to the function, and the point t is given. Try to try to draw a picture so that it tells you what to do. Okay, this function is f function, and this line is just a line, y line there. And I want to use the information given in the problem to find a, b, and c. One standard thing is very simple. You see this point is lying on the line and on the curve. This is a Ma3c problem. If a point is on a function, if the function is line, it doesn't matter. If the function is a curve, doesn't matter. Whenever you have a point on a function, the coordinates of the point should satisfy the equation of your function. So how many functions are involved in this picture? 2. One of them is the straight line, one of them is this curve. And the point of tangency lies both on both the line and the curve. Okay, so you write like this. T is on the line. From this statement, what can I conclude? Everyone, what can I conclude? I can conclude the coordinates of the point satisfy the equation of the line. The equation of the line is here. The coordinates of the point are here. Instead of y, you put 2. Instead of x, you put 1. So it becomes 2 equals to 3 times 1 plus a. And this is even simpler than any E-level question in Ma3c. You want to find a. So 3 times 1 is 3. You move it to the other side. It becomes minus 3. So what is a? A is minus 1. As simple as that. You see, the algebra is just this part. But you can see, because you analyze this in a scratch paper, with your eyes, you can see that this point also lies on the curve. But the same principle will work. The coordinates of the point should satisfy the equation of the function. And if you know a little bit about functions, you know that another name for f of x is just simply y. So you have y, you have x's, you replace y with 2, and you replace x's with 1. So what happens? So I would say t is on the function, on the graph, or on the curve. Then from this, I can conclude that instead of y, I put 2. Instead of x, I put 1. But everywhere, here is x, I get this. Yes? And then what can I write? B, 1 squared is just 1, so it becomes b plus c. But this 1, I move it to the other side, becomes 2 minus 1, which is 1. But this is something I cannot solve because this is just one equation, but I have two missing. I have two unknowns, so I have to another. So which information is not used so far? And that is the reason probably they have given us that information. I use this point for this. I use this point for this. There is something I haven't used. Yes?
The fact that they touch upon each other.
Tangent, yes. This is information tangent is something this thing so far is Ma3c. But this is the first time I want to use Ma3c knowledge, and that is the slope. Because can I read the slope of the tangent? Yes, by looking at the function from Ma3c, you know this is k value. So y is equal to 3 of x of a is tangent. So this means that the k value of the tangent is what? Is 3. This is based on the information in the problem. But in Ma3c, we also learned how to calculate the k value of the tangent myself. What was the rule? I go to your function, I go to my function, I differentiate. The function becomes what? 2bx plus 1. If you have forgotten how to differentiate this, review the previous lesson. It is the extremely simple differentiation. And now, if I want to find the k value of the tangent, what should I do? I have to differentiate my function. I did. And then I replace the x with the x coordinate of the point of tangency. If you have forgotten, let me draw this picture. This is probably the most important picture you have to remember. If you have this, if you have a curve, and if you have this tangent line, this is y equals to f of x, and this point is the point of tangency, its x coordinate is a, k value of the tangent is f prime at a. But you need to remember what a is. If someone asks you what a is, you will tell a is the x coordinate of the point of tangency. So now I want to find the k of tangent. So what should I do? I need to calculate the derivative. I did. Then I have to replace x with a. What is a? A is the x coordinate of the point of tangency. So k value becomes what? 2b times 1 plus 1, which is 2b plus 1. So k tangent, according to my calculation, is 2b plus 1. The same quantity k tangent, using the information given in the problem, is 3. If I want to make it right, these two numbers should match. Okay, because they are calculating the same quantity. So it means that 2b plus 1 should be equal to what? 3. So then it means that b is equal to 2b is equal to 2. So b is equal to 1. Okay, b is equal to 1. b plus c is 1. So b is 1 plus c is equal to 1. So simply c is what? 0. So you see, every step, the algebra is completely minimal. But I will consider it a A-level problem because the people who understand what is going, they can solve the problem. By the way, this idea, even in level 3 problems in the book, will repeat itself over and over. So if you have a point of tangency, the coordinates should satisfy the equation of the line as well as the equation of the curve. So this is something, if you think you will forget, you can take some notes about it. It's very simple. But what is the question mark finally? A minus B plus 2C. What is that? A is minus 1, B is 1, so minus 1, C is 0. If you calculate this, it is simply minus 2. So the answer to this problem is just minus 2. Any questions? This is a A-level question, and this can happen in the national exam. And the algebra is very minimal, so take experience. If you think you will forget, take some notes, some remarks, that by reading them during the exam night, you can immediately remember all of them. Yes?
Do you think the math part on the how school approve it is harder or the national exam?
What?
Do you think the math part on the how school approve it is harder?
I haven't seen. No. How school approve it math is very simple.
Oh, it is.
But the problem is that you have to do it very fast. Every question 90 seconds or something.
Oh.
Yes. So that is why Hawk School Approve It is not a good option if you want. By the way, the questions we can check, some of them are extremely simple. It doesn't even need the notion of derivative. So Ma3c and Ma3c, I shouldn't record these. Let us go to the next problem. The next problem is a little bit hard one. I will follow two methods for solving the problem. The second method does not use the notion of derivative, but I want you to learn that because it facilitates the work a lot. So from among these questions, question number 2 is a good question. Let us read it. If the line y equals to 8x plus b is tangent to the graph of this function at a point on the right-hand side of the origin, we will see where this information becomes relevant. Then what is b? So this is what is wanted. I will solve this problem, as I told you, in two different ways. The first one, which is probably the intention in Ma3c, is to use the notion of derivative. But there is another alternative to solve this problem without the notion of derivative. But I will ask your opinion about that, then we will discuss. But for the time being, let us try to understand the problem. What does it say? So the line is given. When I say it is given, to be honest, it is a little bit of lie. Why? Because if a line is given, I shouldn't have this missing number in it. So when I say it is given, if the form is given, b is still missing. But we know something. We know that this graph is tangent to this function, y equals to 1 minus 2 over x. We know that this is supposed to be tangent to this. The question is that what b is. Okay. So, how should I solve the problem? This problem is a harder one than the previous one. Why? In the previous problem, the point of tangency was given to me. It was 1 and 2. But here, they are not even giving that point to us. So by changing b, this line will change. Because if I change b, you know that the line will go parallel to itself up and down, because the k value is the same. For some choice or choices of b, that line touches this curve. We want to find that particular value or values for b. So this problem is a harder than one, because the other one, the previous one, I had the coordinates of the point of tangency. And I need it. Why? Because this formula only works if you have the x-coordinate of the point of tangency. Otherwise, I will not be able to find the k value of the tangent line using this one. Again, I want to start from scratch. Assume that this is an exam. You go to a scratch paper, you try to analyze the problem. And don't be precise. Don't even care about drawing these precisely. You just draw some coordinate system. You know you have a line. You know that you have a curve. So let us draw this for the curve. Okay, y is equal to 1 minus 2 over x. And let me draw this for tangent. I don't know where it is, but let us call it t. And this is my line. Okay? So, if this is going to be useful for this problem, I need to calculate the derivative of the function and calculate the derivative at the x-coordinate of the point of tangency. Yes? So, but what the point of tangency is, I don't know. So what should I do?
You can maybe first put an equality on the two things because you know that they have the same y value, and you can maybe isolate b.
Okay, but that should be a practical thing to say.
Yes.
But it is not working, is it?
Maybe. I don't know.
No, I want you to see without doing, because in the exam you don't have time to do a lot of trial and error. There is some logic to what you are saying, but you need to understand the logic. Okay, but let us try to teach you in this way. This t is not given to me, okay? I pretend I know about it. I will call it alpha and beta. Of course, this is somehow cheating. I don't know alpha, I don't know beta. But let us see how it will work. I myself call it alpha and beta. But again, the same story starts. Yes? If this is alpha and beta, then it will fit this equation and also that equation. Yes, this is on the one hand. On the other hand, I can calculate the slope. The function is y equals to 1 minus 2 over x. I want to find the slope pretending that I know alpha. Okay, so let us do that. In order to do that, what should I do? I take the derivative, but do you remember? This is E-level question. How can I differentiate this? I have to write 1 minus 2 x to power minus 1. And then I differentiate it. Very simple. The derivative of 1 is 0. Minus 1 goes down. It becomes positive. X to the power of 1 unit less, which becomes minus 2. But usually negative powers are not very good to work with. I bring it down again, so it becomes y over 2 over x to the power of 2. So that is my derivative. But if I ask you what is the k value of the tangent, what do you answer? K value of the tangent means take the derivative, I did it, replace x with the x coordinate of the point of tangency. So what is that? 2 over alpha squared. If someone asks you, Bobak, what did you do? I say that, okay, I found the k value of the tangent myself, but do I need that? No, because this was given in the problem from the beginning. What was the k value of the tangent?
8.
It was 8. So this number that was given in the problem and this number that I did it, they should match. So what happens? 2 over alpha squared should be equal to 8. And this should be a simple problem for you. It's a simple Ma3c problem. What I'm supposed to do, get rid of fractions. So I multiply everything by alpha squared. So this becomes 8 alpha squared is equal to 2. But I isolate alpha squared. So it becomes alpha squared is equal to 2 over 8, which is 1 over 4. But then what happens for alpha? Either 1/2 or minus a half. But read the problem carefully again. This is why they have given you that piece of information. At a point on the right-hand side of the origin. So what does it mean? It means that this point, I don't know if it is above the x-axis or not, but I know the point of tangency is on the right-hand side of the origin. So alpha cannot be negative. So which one is acceptable? 1/2. Not acceptable, yes? In this problem, of course. Okay, do you see that? I didn't know the point of tangency. Using this idea, I was able to find the x-coordinate of the point of tangency. Now tell me, how can I find the y-coordinate of the point of tangency? Exactly this problem. So you see, these ideas are very limited, but they are repeating themselves over and over again. So this point should satisfy the equation of the tangent and equation of the function. Yes? Which one is better in this case? Both of them are true, but which one is useful and true? Yes?
The curve.
The function. Why? Because there is no other unknown in it. In this one, there is another unknown in it. So I will choose this one. Okay, can you tell me what should I write? Instead of y, I put beta. So t is on the curve. It means what? It means instead of y, I can put beta. instead of x, I can put alpha. But I know alpha, so I continue. So it is 1 minus 2 over 1 over 2. But what is 2 over 1 over 2? It's just simply 4. And it becomes minus 3. So beta is also found. Okay, so t is 1/2 and minus 3. Then you can criticize me, Bob, like we are supposed to find b. You found everything except what we were supposed to find. But now it is everything ready. Why? Because this point also is on the line. The same idea. I am using it over and over again. So what happens? T is on the line. So what happens? This means that instead of y of the line you put beta, instead of x of the line you put alpha, it should match. But beta is known, alpha is known, the only missing one, which the problem wants, is just found, yes? So I just continue, instead of beta I put minus 3, instead of alpha I put 1/2, and then b is unknown. But this one is just 4, move 4 to the other side, minus 4, so b becomes minus 7. And that is the answer to the problem. Okay, so this is how they expect you to solve it in Ma3c. But there is an alternative which somehow is similar to what Hasbulat was saying, but I want you to understand why that method is going to work, if it is going to work. Okay, but before that, I would say that the simulation that I will show on you on GeoGebra will actually make you understand this problem better. Okay, so let us try to understand this. Of course, here, this function, you will not study how to draw the graph of it until Mat4. It is not one branch. When you ask GeoGebra to draw the graph, you will see 2 graphs will appear. It doesn't mean there are 2 functions involved. That is one function with 2 branches. But these are nuances. You don't need to be worried about that. Okay, so let me see if everything works here. I would type here y equals to what? 1 minus 2 over x. So as I predicted, there are 2 branches for this function, but together there is the graph of one function. And then I will ask GeoGebra to draw this. I don't know how much you remember. Just make sure that you really care about learning GeoGebra. If I write 8x plus b, and let me put a space here, sometimes it gets confused. B. What do you expect if I press enter?
A straight line.
No. Be careful. You are in technique program. If I ask GeoGebra to draw that, GeoGebra will not be able to draw it. Why?
Because there is not enough information.
Information B is missing, so GeoGebra does not know. This is why GeoGebra is programmed to introduce a slider for you. Okay, and by default, that slider goes from -5 to 5, but you can change the defaults. But what happens, you see what is happening, by moving this, by changing the value of B, the line is actually moving in its parallel form, and then the hope is that if my calculation is correct, if I choose b to be -7, I see that my graph touches the function. Okay, so if you don't mind, let me change the setting. You go to setting, a slider, and then instead of this one, if you don't mind, let me choose from -10 up to 10. Yes, is it working? Yes. Okay, now look. So let me start moving it. I expect, so for example, let me go to the left. Oh, sorry, I have to start from here. I go to the left. What is the value of b now? It's 2.7. Okay, I go to the left. When I reach to -7, what do you expect? Yes, let us see if it touches before that. No, it didn't touch, so, oh, it doesn't go there. So I don't know why I cannot. So let me increase this a little bit. So that, okay, it is not touching, you know. At -6 is 6.8, it is not touching. But can I find the unit? No, it's very hard for me to keep it exact. Oh, I did, and that touches. So this means that what we did calculationally, before seeing GeoGebra, we were able to find the exact value for b, so that when b is that number, this will touch the graph. And now, can you see there is another number graphically? You see, instead of going to the left that touches this branch, I can go to the right. You see? Let us guess this one and then calculate later. It is not touching yet. Not yet. I think it should be 9. Do you agree? So it seems that at 9 it really touches. Yes, it seems so. Okay, so there is another alternative which the calculation missed to calculate. Do you know why? Why we couldn't find that answer 9 in my calculation? Why it doesn't appear? Yes, because here we dropped and say this is unacceptable. If I have chosen that one and did the calculation once more for -0.5, then my prediction is that I could have got this number 9 again. But I want you to understand what you are doing when you are calculating things. Otherwise, it is useless. Okay, is that understandable what we did? Yes, you can test yourself. You can put alpha equals to -0.5 and do the rest of the calculation. I'm sure that you will get b equals to 9 this time. Okay? The problem, I wanted to make it a little bit simpler, so I told you that this is on the right-hand side, so you don't have to do things two times. But now let us go back to the problem. Another problem which is not in the book, the solution is simpler. So if you write it down in the national exam question, the solution, I will accept it from you, even though I want you to understand why it works. Okay? So more or less what Hasbulat is saying, I want to repeat it here, but I want you to understand it as well. So which one I should delete? So let me delete the one above, so let me also pause recording. Let me ask your opinion. If I give you a function, okay, with some equations, I want you to understand why the second method will work. Y equals to f of x, and then if I give you a straight line, let us say that this is like a parabola, for example. And then if I give you a straight line, the straight line have 3 scenarios with respect to this. Either the straight line might go from here, no intersection points, or might be cuts the curve at 2 points, or in somewhere in the middle means touches the graph. Do you agree?
Yes.
Okay, so if I have some curve which is like parabola, and I have a straight line, that the straight line might cut my parabola in 2 points, no points, or 1 point. When it cuts the curve at 1 point, it means it touches that, so it means it is tangent. Okay, but how can I find the intersection point between a line and a curve? For example, I give you this equation. I don't know, for example, x squared. This is a parabola. And I give you a line, which is x plus 1. And I ask you in the exam, Ma3c, find the intersection point between this parabola and the line. What do you do? Yes? Yes, you put them equal and solve them. For example, when I put them equal, it becomes x squared plus 1. And then you start solving it. Be careful about this point that I'm talking about. Is equal to 0. Can you tell me, when I solve this and find the answers, what are the geometrical interpretations of the answer I get from here? Of course, if I solve them, I get numbers. What is the meaning of those numbers in geometrical sense? Yes?
All the points where all the x values where they intersect.
Yes, so it means that these are the x coordinates of these points. Yes, these are the x coordinates of these points. So, this is a quadratic equation. If the intersection is a quadratic equation, how many scenarios are going for a quadratic equation? 3. If the discriminant is positive, 2 points, 2 solutions. If the discriminant is negative, no solutions. But if the discriminant is 0, it means that I have 1 solution. 1 solution is interpreted as being tangent. So if you have a line, and you want to have 1 intersection point with a parabola-like curve, it means that your line is tangent if there is 1 intersection point. Is that understandable?
Yes.
So that is the idea behind this method that I want to present now. So what you do, your function is given to be 1 minus 2 over x. That was my function. Is it correct? Yes. And the line was what? This line. What I want to do, I want to find the intersection point between this and that and force the equation to have one solution. Because in that case, I will have only one intersection point. So what I will do, I will equate them. So it becomes 1 minus 2 over x is equal to, so let me write this one on the left, doesn't matter. 8x plus b equals to what? 1 minus 2 over x. Yes, do you agree what I'm doing?
Yes.
What you said, Hasbulat, was this. But I want you to understand how to continue. That is important. I want to solve this. I can pretend that I'm solving it by multiplying everything by x. And because you see this is a quadratic equation, to solve that, I have to move everything to the left. And then, of course, because x appears here and there, it is not the standard one yet. I would factor x out. And this suddenly becomes a chapter 1 problem. Okay, I get this equation. To make sure that you understand what I am doing, let me ask you again. If I can solve this equation and find x, what is the meaning of those x's? What is the meaning of those x's? Again, that is the same question. What is that? The x coordinates of the intersection points. But how many intersection points I demand? 1. So this is a quadratic equation with some parameter b in it. I want to force this to have one single solution. What does it mean? It means that I have to put the discriminant of this equal to 0. The discriminant, this is the b, so it becomes b minus 1 squared minus 4 times this times that is 64. This should be equal to 0. I move 64 to the other side, and then I get two answers. B minus 1 is 8, b minus 1 is minus 8. So this gives me, do you remember? We could guess. This solution also gives you the second option, b equals to 9 that we got from GeoGebra. And this one is what? Minus 7 that I got in my solution. But you know from GeoGebra, both of them are correct. And this method also gave us both of them. Okay, but in the previous method, you could also get both of them. The reason we got one of them, because we ignored this one. Yes? But here we got both of them. But you also have some problem, because for this problem, both of them is not acceptable. Now by GeoGebra, you know which one is acceptable. But how should you know, in principle, which one is acceptable if you don't have access to GeoGebra now? First of all, before answering this question, do you appreciate the difference? So it is very straightforward. You don't need to do some algebra or some derivative at all. I didn't use the notion of derivative at all. I used the idea that if the line is supposed to be tangent to the curve, it means that if the intersection is a quadratic equation, I have to demand that the discriminant should be 0, guaranteeing that I have one point of intersection, which can be interpreted as tangent. Okay? So this, I don't know. If you do it in this way in the exam, of course I will accept it. And this is very well known in Cambridge A-level ones. For some reason, I don't know why they don't talk about this in this Swedish system, but because might be they want you to really understand the connection between the curve and the derivative and things like that. But that is also a very important one. But now let me ask you the last question. If I insisted to do it in this way, still I get two answers. How should I know which one is acceptable? We now know this one is acceptable, but how should I understand that? Or another question, can I ask you to find the point of tangency? Be careful. Here, the point of tangency is found first, yes, and then using the point of tangency, I was able to find B. But in this new method, what is found first? B. If I want, I can find the point of tangency But tell me how. How can I find the point of tangency now? The people who understand what it is going, they can answer. Yes, John?
Maybe by replacing b and then finding the x squared.
Exactly, exactly. So what we'll do, so let me just do it for this one that you know is wrong. Okay, so let us say I put 9 there, it becomes 8x squared plus 8x plus 2. Everything is divisible by 2. Let me divide by 2 to simplify. You can use PQ formula, ABC formula, but I hope that you know this is the squaring pattern, which is what? 2x plus 1. The first one squared, 2 times the first one times the second one squared, and it means that x is minus a half, which is not acceptable, yes? Why? Because it is on the left-hand side of the origin, yes? So the priority is changed. In the previous method, the tangency point is found first, then b is found. In this problem, b is found. If you need, you can also find the point of tangency, yes? If not needed, you don't even bother to calculate. Okay, please let me know if you don't understand something at this point. Do you understand both methods?
Yes.
Okay. You?
Yeah, yeah.
Okay. So that is up to you which one you use. I would recommend you to know both. Okay? So now let us go to the next problem. Should I wait for you to do it? You see, again, here, this is another problem. The context seems different, but if I want to solve it, you will see that I will repeat the same few sentences again. Let me read the problem for you first. In the following figure, the line L is tangent to the graph of the function y equals to 4x minus x squared at the point t, alpha and beta. Again, alpha and beta are missing. What is alpha squared plus beta squared? You want to calculate and find one of the answers. I would recommend you to start thinking a little bit about so that I can erase the board, make it proper, so that we can write on it. Okay, so again, you will see that I will do the same thing, more or less. So let us go back here. How can I use this piece of information, 9? Because this is a line, straight line. It's the point of tangency is t, but this 9 is only given to me. So how can I use this 9? This is called the y-intercept of your line. Yes, because the tangent line is also a line. So the general form of your line should be kx plus m, as you already know. But here we don't have access to the k value directly, but we have access to m value. And m value is what? 9. Everyone see that. So m is 9. So it means that the tangent line, which is the line L, is still missing part. K is still missing, but at least m is 9. This is what I know. What is the coordinate of the point of tangency? I don't know, but it is given to be alpha and beta. You see, I am using exactly the same thing I used two times. The point of tangency satisfies the equation of the function. The point of tangency satisfy the equation of the line. Again, I am using it this is the third time I am using the same fact. So I would say that because this is on this line, what does it mean? It means that when I replace y with beta, when I replace k with alpha, this should work. Okay. I should also be able to do the same thing here. So what should I do? Beta is equal to 4 alpha minus alpha squared. But I want you to learn, don't start manipulating these equations. There is no way you can find the answer. Why? Just by manipulating these equations.
Two equations.
Yes, this is very important. I have two pieces of information, but how many unknowns are involved? Alpha, beta, and k itself. So don't keep them here. They are relevant, but don't start working them out because it just kills your time. I need another piece of information which comes from Ma3c lesson. Yes, Omar, do you want to say something? No. You? Derivative. So how should I do that? I go to the derivative. This is the simplest possible function for derivative. It's 4 minus 2x. So what is the k value? Do you remember? K value is the derivative at the x coordinate of the point of tangency. So this is my derivative. I replace the x with the x coordinate. So it becomes 4 minus 2 alpha. Now look again. How many equations I have? 3. How many unknowns I have? 3. So everything matches. And by the way, if there are, for example, 3 points for this one, might be you get 1.5 just by writing them. Which is very simple. Okay? Now I want to solve the equation. What was my goal? My goal is to find alpha and beta. So it shows me I have to get rid of k, because I don't need this in this problem. So this motivates me to replace k here, to get rid of k. So here, well, let me write. Beta is equal to, instead of k, I put that expression. This is instead of k. After k, I have alpha. After that, I have plus 9. I simplify this a bit. So beta is 4 alpha minus 2 alpha squared plus 9. This is another equation. This is beta. This one is also beta. They have to be equal. So I would say that 4 alpha minus alpha squared, which is beta, should match with this quantity, which is also beta. And then this 4 alpha and 4 alpha are gone. I move this to the other side. It becomes positive 2 alpha squared minus alpha squared is just alpha squared, and is 9. And everyone knows alpha is minus 3 or plus 3. But in this picture, one of them is definitely not acceptable. Because you see that the point T is in the first quadrant. In the first quadrant, T cannot be negative. So this is not acceptable in this problem. Alpha is 3. But the question mark is alpha squared plus beta squared. So I need alpha, I need beta. But that is very simple. How can I find beta? I can put alpha here to find beta, if you want to. You can put alpha here to find beta. It will give you the same answers. But which one is preferable? I prefer to put in the simpler one. So beta is what? Beta is equal to 4 times alpha minus alpha squared. So it is 12 minus 9, which is 3. So beta is also 3. But the question mark is alpha squared plus beta squared. So it becomes 3 squared plus 3 squared, 9 plus 9, which is 18. And then you see that how similar this problem is to the previous problems. I am just using that idea over and over again. Yes, please.
Is it possible, I think it might be, to do this problem, but you have to find m first?
K first.
M. The nine.
No, MK is the given.
Yeah, I know, but if it's not given, is the problem possible?
Well, how? In the way that I described?
No, not in the way that you described, but you have this problem except you don't get the information that m is 9.
Okay.
Is that possible to solve them?
Ah, you mean that if I don't have access to M at all?
Yeah. Can you find m and then do it, can you solve it some other way?
No, geometrically, no.
No.
No, because you know why? Because if I don't have that anchor to keep my line there, this line could be any line. Yes? It's a good question. You mean, because you know this point T is the point of tangency of this particular line. If I don't have this anchor to keep my line there, then I might have this tangent, I must have this tangent, you know, can have infinitely many tangents. So I would say no, M is necessary from geometrical point of view. From algebraic point of view, you can also do M is necessary, because if M was not given, then how many unknowns I will have? I will have 4, but how many equations I can construct? Only 3.
But I thought if you look there, you see plus 9, right?
Yes?
So replace that 9 with m, and you see that it only touches once. Can't you do what you did in the previous problem? Equals to, you did the discriminant.
No, I
equals to
don't
0.
think it will work, but I have to think, because I use the tangency for one equation,
Yes.
you know, so it means that it will not give me another independent equation. Do you see what I mean? Because I understand what you mean. You say that, okay, I don't know m, so I use another method to, okay, say that if I equate them, there should be a discriminant 0 or something like that. But definitely it will not give rise to a new equation, because that equation is inherited here itself. You can go home and think about it. Yes, but I agree with you. You mean that you take this m, you do this, you do this, you do this, and instead of having 9, you will have m,
Yes.
and then you say that, okay, now we go backward to what I told you in the previous problem, equate them and get another equation. But that equation will not be independent of the information that you have. That is why it is not possible. This is my impression. And from geometrical picture, it's also clear that if that 9 is not there, I have infinitely many lines that can be tangent to this. Okay, so now let us go to the next problem, which is a good problem, I would say. It's exactly at the right level. If this function is given to be this, I just want you to calculate f prime square root of 2. And this problem is a very standard problem in Ma3c. The only thing that makes this problem A-level question because this function is complicated. But if the function is simple and I want you to calculate this, what do? You first differentiate, it becomes a function, then you replace x with the number. But the problem here is a little bit harder. So you can think about it until I write the problem on the board. So what do you think I should do? Let me ask you this question. Do you know that if I give you f of x equals to just 2x squared plus 5, for example, and I ask you the same question, what do?
You just replace
No, be careful, not replace first.
derivative.
First, this is extreme, that is the whole point.
Yes.
If you replace first, it is wrong. F prime of a square root of 2 means first differentiate, which is 4x, then replace, which becomes 4 square root of 2, as simple as that. This problem essentially is the same, but the function is more complicated, so differentiation process is more involved. So how should I do that here? I hope that you remember I told you several times that we don't have any product rule available. Even if you have access to the product rule in Mat4, it is not easy to solve this problem using the product rule at all. So there's only one alternative left for you, is to be a little bit creative to simplify this as fast as possible. The reason I am saying as fast as possible, because the naive way, and correct way of course, is to multiply this here, find the answer, multiply this here, find the answer, multiply it here, find the answer, and then add up. And the exam time will be finished. So you have to find a wise way to do it. And can you see that? It's not very hard. What should I do? Conjugate. So here, 1 number, 2, 3, 4 numbers I want to multiply. No one has forced me to do it in order. So I prefer to multiply these two. You know the answer, which is x squared minus 1. Then suddenly something new happens. This one, which is the answer of this product, will make another conjugate rule pattern with this one. So can you tell me finally what is the answer to the whole part? X to the power of 4 minus 1. That was the hard part. So what I will do, I will say that f of x is equal to, and I told you last time, do you remember, whenever you have fractions, you have to avoid them. How should I do that? This should be interpreted as 2/5 multiplied by x. And instead of this expression, I just simply write x to the power of 4 minus 1, and then I have plus the square root of 2. But still, it is not enough because I have another product left. So then I will multiply. So what happens? F of x becomes 2/5 multiplied here. So 2/5 x, x to the 4th, it becomes x to the 5. And this one multiplied here. And finally this one. And now, after this level, it is E-level question. So you just differentiate this function. Can you do it in your head?
Yes.
So what should I do? 2/5 is a constant, I keep it, but 5 comes down. The 5 that comes down will cancel that 5, it becomes 2. X to the power of 4. Minus 2 over 5 goes outside, and then I keep it, let me just write it. And the derivative of x is famous, it's 1. What is the derivative of square root of 2? 0. That is your derivative. And now the question mark is to calculate f prime of 2, square root of 2. So this means that f prime of square root of 2 I have to replace my x's, there is only one x involved here, by square root of 2 to the power of 4, and then I have 2 over 5. So what is the square root of 2 to the power of 4? Means the square root of 2 to the power of 2, again to the power of 2. So this becomes 2 to the power of 2, which is 4 times 2, 8. So you can write 7 comma 6, for example, because this is exact value, or if you want, you can write, 40 minus 2, 38 over 5. Both of them are acceptable in this case, because that one is exact value. Yes?
Oh, never mind.
Not?
Nothing.
Okay. Any questions? The next problem. This is also a good problem. I want you to understand what is it going here. Consider the following limit. If one calculates this limit and simplifies it as much as possible, the answer is this, where m, n, p, and q are positive integers such that, it's a declarative sentence, is that such that m plus n plus p plus q is equal to what?
Oh, that seems
Okay.
simple.
So, first of all, the question might seem not relevant, because what I'm asking you in this question, essentially, I'm asking you to calculate a limit. You might say that, Bobek, limit was the lesson in chapter 1. Why you are asking limit again here? Because I have a different purpose. First of all, I don't know how many of you remember. Did I teach you how to calculate this limit? The answer is, did I teach you how to calculate this limit? The answer is, the answer is,
Yes.
the answer is,
Yes.
the answer is no. Yes? Why is no? Because it is the third root. The third root, for some reason, is not in the same, in Swedish system, they don't study what happens in the third root. If you are good in algebra, you are studying on your own, you can calculate this limit using another identity, not a conjugate root, to get rid of these third signs. These third signs are with the third the third root, and conjugate is not suitable to get rid of them. Okay, so that is why I didn't teach you, because that was not part of your course, even though it is not hard to calculate this. But even I know how to do it myself, I will never do it in that way. I will use the notion of derivative to calculate. Why is that? Because I don't know, can you feel that this has somehow a connection to what we learned as derivative or not?
Yes.
What kind of feeling you have about it?
Because I have seen that somewhere.
Okay, so where the definition of the derivative? So what was the definition of the derivative? If you have forgotten, it is in the formula sheet. So it is f of x plus h minus f of x divided by h goes to 0. This is the derivative limit structure. This is the limit demanded in the problem. I hope that you can see similarities somehow and to discover what is playing the role of your function in that limit. It's a matter of seconds. What is the guess? What do you guess for f of x here by looking at this?
Very good.
Yes. This is your rough guess or educated guess. It seems that f of x, which is the third root of 5x, does the job. But you have to confirm that it does the job. What do I need by confirm? I should confirm that this one becomes exactly this one. Is it?
Yes.
Yes, let us calculate. F of x plus h means go to your function that you are guessing is the correct one. Replace your x with x plus h. Is this the one coming here? Yes, because you multiply 5. And that is exactly what you see here. So, you see, it was not hard. As soon as you have the feeling that this is related to the definition of the derivative, you write the formula from the formula sheet and compare. Your first educated guess is that, okay, if this is going to work, f of x should be this one. but it is not guaranteed yet. I have to check that this one also becomes this, which I did. Now everything is in order. If everything is in order, this means that this limit is what? This limit is equal to the derivative of what? Of that function. Okay? This is a tricky point. Sometimes I see in the national exam they ask these kind of questions that you understand the relation between derivatives. And the logic is, to be honest, is completely different. We use limits to find derivatives, but they have designed the question in another way. You use derivative to find limits. That is the whole point. Why? Because if your differentiation is good, differentiation in this case is much faster than calculating the limit, even if you know how to calculate the limit. Yes?
So then you find the
Derivative of this one, that's your answer. But how can I calculate the derivative? This I would say is a C-level question. Understanding the connection makes it an A-level question, but this one is itself a C-level question. How can I differentiate this?
You do the third root of 5 and of x, right? And then after that you pull at one third.
Yeah, so what he said is completely right. It is extremely important to separate them first. So, because I have a formula that the nth root of a times b, it can be written as the nth root of a times the nth root of b. The nth root of a over b can be written as the nth root of a over the nth root of b, but don't push it further because for addition and subtraction it is wrong. So no one tells that the nth root of a plus b is equal to the nth root of a plus nth root of b. If you think this is also correct, I have to correct you. That's not correct. Okay, so what I will do, I will say as you told me, I will separate them first, and everything will be ready to differentiate. How? I would write that f of x is equal to, let me write everything in front of your eyes, the third root of 5x, this is multiplication, so I can write it as the third root of 5 multiplied by the third root of x. Third root of 5 is just a constant, so I don't need to be worried about. But this one we learned what to do. X to the power of 1/3. And then I differentiate. The differentiation rules tell me that you can keep this constant here and just differentiate here. 1/3 goes down. X to each power, 1/3 minus a 1. Minus 2/3. Yes? Okay. I mean, the problem is finished, to be honest here, but because I want to make it an autocorrect version of that, I have to be a little bit creative here. So what I did, I would write it in this form. I would write it as 1/3 first, third root of 5 second, and then I bring it down to make it with positive power. But can you write this back in the form of a third sign? So 1/3 is here. This will be multiplied here. But this can also be written as a third sign. The third root of, no, I made a mistake, sorry. This was 2/3 minus, when I bring it down, it remains 2/3 but positive. Sorry, that was my mistake. So now 3 goes up here, x to power 2 goes there. And now, according to this rule, I can write it as 1/3 sign. So I copy and paste a third. The third root of 5 over, this is the answer. And then this answer should be compared with what is given there. What is given there? 1/m p x to power q. So then you can read them. What is m?
3.
M is 3, n is 3, p is 5, q is 2. When you add them, what is the answer? 13. So the question mark is 13. Okay? Any questions? Okay, let us go to the next problem. Consider the following function. this is given. If the tangent line to the graph of this function at the point where the x-coordinate is -1 is perpendicular to the line ax minus 18y equals to 3, then what is A?
What is perpendicular?
Perpendicular means intersecting with right angle. How do you say it in Swedish? Yeah, right that, yes. Yeah, two lines are perpendicular.
Okay.
So we say that if this is 90, L1, L2, we say L1 is perpendicular to L2.
Yes.
Yes. Okay, but because we have finished much earlier than I thought, so let me give you 5 minutes so that you can think about this problem yourself. I mean, you still see that everything repeats itself. So, yeah, try to read the problem, analyze it yourself, and then try to solve it. After 5 minutes, I will come back and solve it together, and then we will finish the lesson today. Okay, so I think at least you know what I'm supposed to do. I have written the information here. This is the function. X-coordinate of the point of tangent is -1, and I know that the given tangent, the tangent to this function at that point is a line. According to the problem, that line is perpendicular to this line. You need something from Ma3c. What is the relation between the k values when the lines are perpendicular? Of course, if you don't know that, there is no way you can solve the problem. If they are parallel, they are the same. But if they are perpendicular, the product is -1. If two lines, so this, if you have forgotten this, of course, there is no way you can solve it. If two lines are parallel, K1 and K2, they are the same. If they are perpendicular, K1 and K2, K1 dot K2 is what? -1. This, if you have forgotten, I don't know if this is in the formula sheet or not, might be it is, but that is you need to know. Anyway, the first part, even if you cannot solve the problem, if there are 3 points, believe me, 1 point, half of it is coming for just differentiation. Okay? So you shouldn't leave the problem blank. But you need to remember something from the previous lesson. You know by the experience you have to separate them, yes? So I will copy and paste the numerator, but the denominator needs some simplification. So this is just 2x, and this one can be written as x to the power of 2/3. But this one and that one will be combined. This is power 1, added to this one. 1 plus 2/3 is 5/3. So I will write the denominator as this one. And now the rule is to divide separately, okay? So this becomes 5/2. This one and that one, so let me do it in 2 steps. Minus this one divided by that one, oh, let me write 1/2, because this is 1, this is 2, and then x divided by x to the power of 5/3. And if you want, of course, it is multiplication. And finally, 1/2, 1 over x to the power of 5/3. This is the way that you have to interpret that, and then you can simplify. 3 minus 5/3, which is 9 minus 5, 4/3. So it becomes x to the power of 4/3. This is -1/2. X to the power of 1 minus 5/3. 1 minus 5/3 is what? 3 minus 5 minus 2/3. And the other one is 1/2. I just bring it up. There's nothing I can do. Now my function is completely ready to be differentiated. And the rule is the same. 4/3 goes down and then subtracted 1 unit. So let me just do it. So f prime of x, I have 5/2. 4/3 goes down. X to the power of 4/3 minus 1. 4/3 minus 1 is 1/3. In this one, minus 2/3 goes down, so it is -1/2 minus 2/3. And then x to the power of minus 2/3 minus 1, which becomes -5/3. And the other one is plus 1/2 minus 5/3 goes down. X to the power of -5/3 minus 1, -8/3. And let me simplify it a little bit more. These 2 and that are cancelled, so it is 10/3. x to the power of 1/3. This minus 2 and that minus 2 are cancelled, so it becomes a third x to the power of minus 5 over 3. And this one becomes minus 5 over 6, x to the power of minus 8 over 3. This is finally my derivative. Okay, but I want to find the slope of the tangent. So the k value of the tangent is the same thing as I usually use. I have to replace x with the x coordinate of tangency. So it becomes 10 over 3 minus 1 to the power of 1/3. I hope that you don't have problems calculating these numbers. They are a little bit tricky, but the number is minus 1. That is the good news. Okay, can you do that?
That's why I was so confused. How can you take it all and then minus?
No, this is not, that is intentionally I did it with minus 1 because I wanted to teach you again to use this opportunity. So minus 1 to the power of 1/3, what is this? Is the third root of minus 1, which is minus 1. Yes? Minus 1 times minus 1 times minus 1 is minus 1. So the third root of minus 1 is minus 1. The second root is not defined. The odd root is defined. So if I have the odd root of minus 1, it's always minus 1. Yes? Okay. So here, this one is minus 1. So it becomes minus 10 over 3. What about this one? If I really want to do it, I have to write it as minus 1 to the power of this. I bring it down, make it positive, but you don't have to spend so much time. And then what do you do here? You write the third root of minus 1 to power 5, but this is minus 1 again, so the answer becomes minus 1. So this is minus a third. Okay, can you do this in your head? Is minus 1 or 1? What?
It's 1.
It's 1, because minus 1, 8 to the power of minus 8 over 3. So it is 1 over minus 1 to the power of 8 over 3. But then it becomes 1 over the third root of minus 1 to power 8. But minus 1 to power 8 is 1. So it becomes just simply 1. So the last one is 1, but I have minus 5 over 6. Yes? And then I take the common denominator to be 6. 2 times minus 20, 2 times minus 2, 1 times minus 5. So it's minus 27 over 6. I divide by 3, minus 9 over 2. So this is the value of the derivative. Okay, so Sandra, did you get this answer?
No.
No. So might be that's the mistake. I don't know if you have made some mistakes here, but I am sure more or less. We can check GeoGebra later, by the way. Don't take my words for granted. So I would say that this is minus 9 over 2. So the k value of the tangent is minus 9 over 2. The k value of the line, what is the k value of the line? Can you read it for me? By the way, how many of you got the k value of the line correctly? How should I read the k value? I have to write it as a standard form. So I move this to the other side, so it's minus 18 y equals to minus ax plus 3. I divide by minus 18, so it becomes a over 18x minus 3 over 18. So this is the k value. Yes, the k value of the line is a over 18. But because they are supposed to be perpendicular, so the k of tangent multiplied by k of the line should be what? Minus 1. Minus 1, yes. K value of the tangent is this. K value of the line is this. And then I am done, yes? Because this minus sign and that minus sign are gone. 9, 1 times, this is 2 times. So it is a over 4 is equal to 1. A is equal to 4. Yes? So the answer, this I told you, this problem is lengthy, but in principle not hard. The other problems I will consider them harder. This is just lengthy. And I told you, this impression that you have to solve the problem completely to get points is not good idea. Because if you just do this part, you get some point. If you can find this derivative until here, it's a very, it takes a lot, it gives you a lot of points. But the rest of it will be just completion of those problems. Okay, so the answer to this problem is also a equals to 4. Any questions? So let me pause recording here. Thank you very much.